Alright, so today I'm going to be talking about like isotopes and how to find them, what they mean, all that kind of stuff. So first we're going to look at a basic one, a basic element, and like how you identify elements in general, and then isotopes. So carbon, its normal atomic mass is going to be around 12, atomic number is 6. So this is the atomic number, and this is the atomic mass. So what this tells you is this is also the number of protons. So we know that this element, this version of carbon has 6 protons, and we know that the atomic mass is the protons plus neutrons. So if there's 6 protons, there's 12 of both of them, we know that there's 6 neutrons. Cool. And normally, carbon is one of the ones, but there's normally the same number of electrons as protons. But that's not really what we're focusing on. We're mainly focusing on protons and neutrons, because that's what's going to be important for isotopes. But that's not always how it's going to be. That's the stable version of carbon. Sometimes you'll get something that looks like this. So still 6 here. The 6 is what makes it carbon. So we still have 6 protons, but now we have 14 here. So now we have 8 neutrons. So now we have a new isotope of carbon. Cool. So the way that we find isotopes, and if you ever look at a periodic table online or the one that you're going to get in class, and we go to carbon, it says that carbon's average atomic mass, which is what you'll see on a periodic table, is 12.011. That's why I said the normal one is this, because normally it is going to have a 12, but see how it still has that 0.011? So sometimes you can have that 14 there. Sometimes it will have a higher mass. So the way we figure that out is something called mass spectrometry. I don't even know if I pronounced that right, but I know what it is. So what it is it's a graph that looks something like this. Sometimes the other axis will be right there. It's straight on my end-ish. Apologies for that. So we have 12, we have 14. This is the just atomic mass units. And then over here we have percent abundance. That's how it's going to be presented. It's kind of straight. So we have a lot of 12. Let's say it's 80. So then over here we're only going to have 20. I'm not good at graphs. Those aren't exact. But what we go from here, and this isn't the exact one for carbon, but yeah. What would go from here is 80%, which is notated as 0.8 when we're doing math, say 0.80 times 12 plus 0.20 times 14. And then we bring out our handy-dandy calculator and do 0.8 times 12 plus 0.2 times 14. And this equals 12.4. So remember the actual one was 0.011. So we don't have an exact fancy version of what it actually is, because the actual one is 12.011. What I got with my made-up thing here was 12.4, but you get the point. I made these numbers up, so it would be easy. But that is what mass spectrometry is, and hold on a second. Since I don't remember where this is taught, like in the curriculum, I'm just going to go and do it here. There's something called experimental error, percent error, stuff like that, and we're going to go ahead and pretend like this was a lab. So what you want is your theoretical minus experimental over your theoretical, or actual, because here we're doing an actual minus experimental. So 12.011 minus 12.4 over 12.011. So let's see what the percent error of my fake lab was. 12.011 minus 12.4 all over 12.011. So, and of course this is times 100 because we're looking for a percent. This was negative 3.238%. So 3% error for a fake lab. It's not too bad. But yeah, that is how you calculate percent error. So yeah, that's all I'm probably going to go over in this video. This one is a little shorter one, but yeah. That's mass spectrometry, isotopes, and all that kind of stuff.